Good morning everyone. In today's video, we'll discuss some numerical problems on metacentric height. I'll read the first problem. A rectangular pontoon is 5 meter long, 3 meter wide and 1.2 meter high. The depth of immersion of the pontoon is 0.8 meter in seawater. If the center of gravity is 0.6 meter above the bottom of the pontoon, determine the metacentric height. Density of seawater is 1025 kg per meter cube. Okay, so first we'll understand the question. Pontoon is nothing but a wooden support, like you might have seen temporary bridges. So under the temporary bridges you can see supporting structures. Those supporting components are called pontoons. So in this problem you have a rectangular pontoon and the dimensions are given. The length is 5 meter, width is 3 meter and the depth or the height is 1.2 meter, and it is immersed in seawater up to a height of 0.8 meter. The center of gravity is 0.6 meter above the bottom of the pontoon. Then determine the metacentric height, and the density of seawater is given as 1025 kg per meter cube. So this is how the figure comes. It is a rectangular body. So the width is 3 meter. This is 3 meter. The depth or the height is 1.2 meter, and the other dimensions which we cannot see is the length, that is also given in the question, 5 meter. So the depth of immersion is also given 0.8 meter. Okay, so here G is the center of gravity of the body and B is the center of buoyancy. Where will G come? G will be coming at the center of the depth. Depth is 1.2 meter. So G is at 0.6 meter from the base. We will mark a reference point A in the base and we will be measuring the height from A. So from A, G is at a height of 0.6 meter. Now what is B? B is the center of buoyancy. Where does the center of buoyancy come? Center of buoyancy comes at the center of gravity of the displaced portion. So this much is the displaced liquid, and the center of gravity of the displaced liquid comes at the center of the depth of immersion. Depth of immersion is 0.8 meter, so the center of buoyancy will come at 0.4 meter from point A. So that is what is marked here, 0.4 meter. So let G be the center of gravity and B be the center of buoyancy. A is the center point of the base of the body. So A is given just for a reference. So from A, this is at 0.6 meter, G is at 0.6 meter, and from A, B is at 0.4 meter. So what I have drawn in the bottom is the plan. That is, when you look from the top, what do you see? So when you look from here, you will be seeing like this, and this length is given as 5 meter. I hope you can imagine the position. So when you look from the top, that is plan. Plan is nothing but the top view. So when you look from the top, you will be seeing like this, and this red marking is the YY axis which is marked here. Okay, I'll tell you why it is marked. So AB, I have already told you, AB is 0.8 by 2, 0.4 meter, and AG is 1.2 by 2, 0.6 meter. We have learned the equation for finding out the metacentric height. Metacentric height is equal to I by V bar minus BG. Okay, so here I is the moment of inertia of the plan of the body. That is why we have drawn the plan of the uh, body here. So when you take this moment of inertia, it is the moment of inertia of the plan of the body about y axis at the water level. So at water level, this is the water level. So at the water level, when you look from the top, about the y axis, whatever is the moment of inertia, that you have to substitute in this I. So I is the moment of inertia of the plan of the body about y axis at water level, and the denominator is V bar. What is V bar? V bar is the volume of the immersed portion alone. It is not the total volume, it is the cut volume or the immersed volume of the immersed portion of the body. And Bg is the distance between B and G. B is the center of buoyancy and G is the center of gravity. So first we will find out I. What is I? I is the moment of inertia of the plan of the body about the y axis. So this is the plan of the body drawn again. This is the y axis. So when you take the moment of inertia of the plan of the body about y axis, the dimension that comes parallel to the y axis is the b dimension. So for a rectangular body, we know that the moment of inertia is b d cube by 12. So the b value is the dimension that is coming parallel to the y axis, because we are taking moment of inertia about the y axis. So b value is 5 meter and d value is this 3 meter. So I is equal to 5 into 3 cube by 12, 11.25 meter raised to 4. Now V bar is the volume of the immersed portion. So see the figure again. So this much is the immersed portion. So what will be the volume of the immersed portion? 0.8 into 3 into the other dimension is 5 meter. So V bar is equal to 3 into 0.8 into 5 meter, 12 meter cube. Now BG as you can see from the figure, BG distance will be equal to AG minus AB. That will give you BG. So BG is equal to AG minus AB. AG is 0.6 meter, which is the center of gravity of the whole body, and AB is 0.4 meter, which is the center of gravity of the immersed portion. So the difference is 0.2 meters. So BG value is 0.2 meters. So we have got all individual values. Substitute it in the equation for metacentric height. GM is equal to I by B bar minus BG. I value is 11.25, B bar is 12, and BG is 0.2. So the metacentric height, you have obtained it as 0.7375 meter. Now we will go to the second problem. A uniform body of size 3 meter long, 2 meter wide and 1 meter deep floats in water. What is the weight of the body if the depth of immersion is zero point 0.8 meter? Determine the metacentric height also. So read the question again. You have a uniform body of size 3 meter long, 2 meter wide and 1 meter deep. It is floating in water. What is the weight of the body if the depth of immersion is zero point 0.8 meter? Determine the metacentric height also. So it's a very simple question. For a floating body, we have learned that the weight of the body is equal to the weight of the water displaced by the body. You are asked to find out, as the first part of the question, you are asked to find out the weight of the body. So in order to get the weight of the body, you can find out the weight of the water displaced by the body. How will you get the weight of the water displaced by the body? What is the volume of water displaced by the body? 0.8 into 2 into 3 meter is the volume of water displaced. That value multiplied by the weight density will give you the weight of the body. So the weight of the body is equal to weight density. Weight of the body is equal to weight of the water displaced by the body. Weight of the water displaced by the body is equal to weight density of water into volume of water displaced by the body. Weight density of water is 1000 into 9.81 and volume of water displaced by the body is equal to 0.8 into 2 into 3. So the weight of the body is 47088 Newton. As the second part of the question, you are also asked to find out the metacentric height. We know the equation Gm is equal to I by V bar minus Bg. First we will write Bg. So just like in the previous question, Ag, that is the actual center of gravity of the whole body, will be at half depth, so 0.5 meter, and AB will be equal to the is at half the depth of the immersion. Immersion depth is 0.8 meter. So AB will be equal to 0.8 by 2.4 meter. So what will be BG? BG will be AG minus AB. 0.5 minus 0.4 is equal to 0.1 meter. and I is the moment of inertia of the plan of the body about the y-y axis at the water level. Again, here also we have drawn the plan, and this is the y-y axis. So about y-y axis you have to take the moment of inertia. So b dimension is the dimension that is coming parallel to the y-y axis. So this 3 meter is the b value. So 3 into 2 cube by 12. So this dimension is 2 meter. This is 2 meter, this is 3 meter, because this is 2 meter, so this will also be 2 meter. So 3 into 2 cube by 12. So the moment of inertia of the plane of the body about y-y axis at the water level is 2 meter raised to 4. Now V bar is the volume of the immersed portion. Easily you can find it out because all the data are given. 2 into 0.8 into 3, 4.8 meter cube. Now the metacentric height, you can substitute the various values. I by V bar minus BG. I is 2 meter, so sorry, 2 meter raised to 4 by V bar is 4.8 meter cube minus BG is zero point 0.1 meter. So substituting all these values, you will get GM as 0.3167 meters. Now the third problem. A solid cylinder of diameter 4 meter has a height of 3 meter. Find the metacentric height of the cylinder when it is floating in water with its axis vertical. The specific gravity of the cylinder is 0.6 meter. So first we'll understand the question. A solid cylinder, you have a solid cylindrical shape body and it has a diameter of 4 meter and a height of 3 meter. Find the metacentric height of the cylinder when it is floating in water with its axis vertical. So it is floating in water and you are asked to find out the metacentric height. The specific gravity of the cylinder is given as 0.6 meter. So as you are aware, the weight of the floating body is weight of the body is equal to weight of the water displaced by the body. You don't have to write this weight of the body again. You can cut it off. So weight of the body is equal to weight of water displaced by the body. So this is the cylindrical body. So when you look from the side, it appears to be a rectangle and the dimensions are 4 meter and 3 meter. Now this is the plan of this figure. Actually it has to come as a proper circle. So when I drew it, it came out like this. So when you draw it, you draw a proper circle. Okay. So weight of the body is equal to the weight of the water displaced by the body. Now what is the weight of the body? Weight of the body will be equal to rho g. What is rho g? Rho g is the weight density multiplied by the volume of the body. So weight density of the body multiplied by the volume of the body is equal to weight of the water displaced. How will you get the weight of the water displaced? Weight density of water multiplied by the volume of water displaced. Okay, so here left hand side you have to use the rho of the body and in right hand side you have to use the rho of water. Why so? Because for a floating body the weight of the body is equal to the weight of water displaced by the body. So now substituting the values, rho value for the cylinder is 0.6 into 1000 into G is 9.81 into volume is, what is the equation for volume of a cylinder? Pi r square h. So pi into radius is 2, so 2 square into height is 3 meter. So substituting the values here, and on the right hand side rho is that of water, so 1000 into G is 9.81 and volume of water displaced will be equal to again pi r square h. Pi into 2 square into h is the depth of immersion because we have to find out the volume of the water displaced. So the amount of displacement is up to this much circumference. So 1000 into 9.8 into pi r square h. So from this equation, h is the only unknown and you can easily solve for the value of h. So when you observe this equation, see uh, on the left hand side, what all things you can cut? 1000 can be cut, 9.81 can be cut, pi can be cut, 2 square can be cut. So all these things can be divided from both the sides. So what is left? H will be equal to 0.6 into 3. That is, when you generalize it, you can say H will be equal to 0.6 into 3. What is 0.6? 0.6 is the specific gravity of the material of the body, and H is the depth of the body. So the height of or the depth of immersion can be obtained from a small formula here. Specific gravity into depth of the body will give you the depth of immersion. Okay, so depth of immersion is equal to specific gravity of the body into height of the floating body. So substituting the values and solving it, finally you will get the value of H as 1.8 meter. Now substituting in metacentric height, Gm is equal to I by V bar minus Bg. So first we will find each of the terms. I is the moment of inertia, pi d raised to 4 by 64, pi into 4 raised to 4 by 64, value is 12.57 meter raised to 4. V bar is the volume of the immersed portion, so that will be equal to pi r square h. Pi into r value is 4 by 2 the whole square into h is the depth of immersion 1.2 meters. So substituting the values, you will get V bar as 22.62 meter cube. Now, just like in the previous two numerical problems, here also you have to find out Bg. Bg is equal to Ag minus Bg. Ag is 3 by 2 minus Bg is 1.8 by 2. So when you look in the figure, these values will be very clear. So Bg, you have obtained it as 0.6 meters. Now substituting the values in the equation for metacentric height, Gm is equal to 12.57 by 22.62 minus 0.6, and you will get the value as minus 0.044 meters. So the metacentric height, you have calculated it and you have got it as minus 0.44 meters. So what does that negative sign indicate? The negative sign means that the metacenter is metacenter is below the center of gravity and the body is in unstable equilibrium. That is, when it is twisted, it may not come back to its original position. So that is what the meaning of the negative symbol is. It means that the body is not in equilibrium. Now we will move on to the next numerical problem. A rectangular pontoon 10 meter long, 7 meter broad and 2.5 meter deep weighs 686.7 kilonewton. It carries on its upper deck an empty boiler of 5 meter diameter weighing 588.6 kilonewton. The center of gravity of the boiler and the pontoon are at their respective centers along a vertical line. Find the metacentric height. Find the metacentric height. The weight density of seawater is given as 10.104 kilonewton per meter cube. Okay, so here also you have a rectangular pontoon and the dimensions are given. The length is 10 meter, width is 7 meter and the depth or the height is 2.5 meter. So here above the pontoon there is a boiler, empty boiler which is cylindrical in shape because the diameter is given. So it is cylindrical in shape having 5 meter diameter and the weight of the boiler is 588.6 kilonewton. So here you have two different bodies. First you have a rectangular pontoon and on the top of that you have a cylindrical boiler. The center of gravity of the boiler and the pontoon are at their respective centers. So definitely the center of gravity will be at the center. For the boiler and the pontoon will be at their respective centers along a vertical line. You are asked to find out the metacentric height and the weight density of seawater is given as 10.104 kilonewton per meter cube. So here you have to note it that you are given not just the density but the weight density is given. What is weight density? Weight density gamma is equal to rho g. So what is given is rho into g. Okay, so remember that. So first we will draw the figure. So you have a rectangular pontoon and on the top of that a cylindrical barrel or boiler is kept. The dimension of the rectangular portion is 10-meter long, 7-meter broad and 2.5-meter deep. So you can see only the 2.5-meter depth and the 7-meter width here. The other dimension 10-meter is the length of the pontoon in the figure. So here you have the rectangular pontoon and the top of that you have a cylindrical boiler. So this is the side view of the setup. So in the figure, let G1 and G2 be the centers of gravity of the rectangular pontoon and the cylindrical boiler respectively. So see the figure. G1 is the center of gravity of the rectangular portion alone and G2 is the center of gravity of the circular portion alone. And let G be the combined center of gravity. So here G is the combined center of gravity. G2 is the center of gravity of the circular portion. G1 is the center of gravity of the cylindrical portion. So what is AG1? AG1 will be equal to half of the depth, isn't it? What is AG1? G1 is the center of gravity of the rectangular portion alone. So where will it come? It will come definitely at the midway bit of the depth. Depth is 2.5 meters. So AG, distance G will be equal to 2.5 by 2, 1.25 meters. Now coming to AG2. AG2 is the distance of the center of gravity of the circular portion from the base. Okay, so that is AG2. So what will be the value? AG2 will be equal to 2.5 plus this diameter is 5 meters, so 5 by 2. So 2.5 plus this distance, which is 5 by 2. So that is value of AG. AG is equal to 2.5 plus 5 by 2. Total is equal to 5 meter. Now these two are the distances of the individual center of gravity from the base. Now you have to find out the combined center of gravity. Let G be the combined center of gravity. So how will the equation come? AG is distance of G from the base of the body. So AG is equal to W1 AG1 plus W2 AG2 by W1 plus W2. I hope you have already learned this equation. So when you have the combined center of gravities, how will you find out the common center of gravity? So AG is the distance of the common center of gravity from the base, that is A to G. So AG is equal to W1 into AG1 plus W2 into AG2 by W1 plus W2. So W1 value is given in the question 686.7. So W1 into AG1. So what is AG1? This we have found it out, 1.25 meter. So 686.7 into 1.25 meter plus W2 is the weight of the cylindrical portion alone, which is 588.6 into AG2 we have found it out 5 meter, divided by W1 plus W2, 686.7 plus 588.6. So AG value you have obtained it as 2.98 meters. Now what are you asked to find out? You are finally asked to find out the metacentric height. So in order to find out the metacentric height, let h small h be the depth of immersion, because in the question it is not given the depth of immersion. So let h be the depth of immersion for the floating body. Now weight of the body is equal to the weight of the fluid displaced. So here what you have to note is, in the left hand side we are talking about the weight of the body, and on the right hand side we are talking about the weight of the fluid displaced. So when you substitute values for the left hand side, it should be for the body, and for the right hand side it should be for the fluid. So weight of the body will be equal to the sum of the individual weights, 686.7 plus 588.6, that is the weight of the body, is equal to the weight of the fluid displaced. How can you find out the weight of the fluid displaced? rho of seawater into G. So when you do rho of seawater into G, what will you get? You will get the weight density rho into G into volume of seawater displaced will give you the weight of the seawater displaced. So rho of seawater into G into volume of seawater displaced. So on the left hand side, the total weight will come to 1275.3 meters. Sorry, not meters, kilonewton. 1275.3 is equal to, now in the question I have mentioned in the question itself that it is the weight density. 10.104 is the weight density, that is in the equation what is given is rho g. Rho g value is 10.104, so you don't have to multiply with 9.81 here. See, even I had done it by mistake by multiplying it with 9.81, so don't do that mistake, because what is given is the weight density. If you are given the mass density, then you have to multiply it with 9.81. Here directly you are given the weight density. So 10.104 into volume of the seawater displaced. How will you get the volume of seawater displaced? 7 into 10 into h. 7 is the width of the body, 10 is the length of the body, and h. Why are we taking h? Because we are finding out the volume of the water displaced. So for that you have to take the depth of immersion alone. So from this equation, h is the only unknown. H is obtained as 1.803 meters. So the depth of immersion is 1.803 meters. Now the distance of the common center of buoyancy B from A. See, this B is the common center of buoyancy. So distance of the common center of buoyancy from A will be equal to h by 2. So h value we have obtained it in the previous step. H value you have obtained it as 1.803 meters. So the distance of the center of buoyancy from the base point A will be equal to 1.803 by 2.902 meters. Now find out BG, because we want to substitute this BG in metacentric height equation. BG is equal to AG minus AB. AG is 2.98 meters, which we have already got, and AB is 0.902 meters, which we have just got. So BG will be equal to 2.078 meters. Now coming to the metacentric height equation, GM is equal to I by V bar minus BG. I, you have to remember that it is the moment of inertia of the plan of the body about y by axis at the liquid level. So you don't have to look from the top and consider the barrel also. Why? Because we are taking the moment of inertia at the water level only. So see, this is the water level. At the water level, what is the shape of the body? That is, if you remove the portion, if you cut the portion above the water level and remove it, what will you see? You will only see a rectangular portion, isn't it? So, in the metacentric height equation, the I is the moment of inertia of the plan of the body about y axis at the liquid level. So, how will you get the values? So, the value will be B dq by 12. B is the value which is coming parallel to the y axis. So the dimension that is coming parallel to the y axis is 10 into width is 7. So 7 cube by 12. So moment of inertia will come to 285.8 meter raised to 4. V bar is the volume of immersion. So for the volume of immersion also we have to consider the depth of immersion. So depth of immersion we have got it as 1.803 meter. So the volume of immersion is 7 into 10 into 1.803, 126.21 meter cube. Substituting the values, GM is equal to I by V bar minus BG. I is 285.8 by V bar is 126.21 and BG is 2.078 meters. So 2.078 meters, substituting and all these values and calculating, you will get the metacentric height as 0.186 meters. Thank you.